Hey guys, welcome to today's video on inequalities. So let me just start off by comparing an inequality to an equation. With equations, one side always equals to the other side, so that's why we see an equal sign, and that's pretty much why they're called equations, because one side equates to the other side. On the other hand, with inequalities, you're going to see these types of signs. You're going to see the greater than sign, greater than or equal to, less than or equal to, because the two sides of our inequality are going to be, you guessed it, unequal. So when you're solving an inequality, it's pretty similar to solving an equation. So I'm writing down negative 4x plus 2 is less than or equal to 16. And we're going to start off the same way as how we would solve an equation. I'm going to subtract 2 on both sides. Negative 4x is less than or equal to 14. Now this is a part where it gets a little different, because once I divide both sides by negative 4, which I must do to isolate my x, I'm going to have to flip the sign to, as you can see, from less than or equal to greater than or equal to. So x is greater than or equal to 7 over negative 2. And the reason why I do this is actually a rule with inequalities, and it's really important, so I'm going to highlight it again on the side. This is a really important rule with inequalities. Every time I divide or multiply by a negative number, negative, oh, every time I divide or multiply by a negative number, I'm going to always flip the sign. I know flip the sign isn't the most mathematical term, but for this case, it'll do. So I got that x is greater than or equal to negative 7. That means any value of x that is higher than this number, which is, this is also negative 3.5, any value that is greater than this can satisfy the requirement for what x has to be. So what I'm going to show you next is a way that we can represent this. So I got that x was greater than or equal to negative 3.5. And I want to show this on a number line because this is a better way to visualize it. So I'm going to draw my number line, maybe like this, starting from negative 6 to, let's see how far I can go. Negative 2, negative 1, 0, 1. And I'm going to pick a different color now when I'm filling out my number line. So this is actually a type of way to represent inequalities. You can use this for any type of problem in the future. So x must be greater than or equal to negative 3.5. That we found out. So I'm going to find negative 3.5 on my number line. It's over here. And I'm going to do a filled in circle. The reason why I fill in my circle is to signify that negative 3.5 is part of the possible solution set. As you'll see later, if it wasn't part of the possible solution set, I wouldn't be filling it in. I'll be leaving it an open circle. But like I said, I'll show you guys that later. So I fill in the circle, and I know that x has to be greater than or equal to negative 3.5. So would that be this side over here or this side over here? Well, all the values of x that are greater than or equal to negative 3.5 are on this side of the number line. So for that reason, I'm going to make my arrow like this to show that all the values of x to the right side of this number line are a possible solution set. And this arrow signifies that the values go on and on and on. Like as you can see here, I have it up to 1, but it can be 5, it could be 15, it could be 432. So that's what the arrow is for. And just to recap, this circle is to show that negative 3.5 is part of the solution set. So this is a valid answer to our inequality. So now that we got that easier example out of the way, let's try something a little bit harder. let's do x squared plus 2x is less than 3. This, now we got some quadratics involved. So what we're going to do is, I recognize that this looks kind of like a quadratic equation. Quick recap, I'm going to write over here what a quadratic equation looks like. It's ax squared plus bx plus c equals 0. Oops. Let me do that again. This notebook is not my friend today. Ax squared plus bx plus c equals 0. So I'm trying to get this inequality in this form over here, so it's easier for me to solve because I already know how to solve a quadratic equation. So I'm going to rewrite that as x squared plus 2x minus 3 is less than 0. I've just subtracted 3 from both sides, effectively bringing over this 3 to this side. Now, from this point forward, I can just factor this. X minus 1, x plus 3. And if this was an equation, my solutions would have been x is equal to 1 and x is equal to negative 3. However, this isn't a regular equation. This is an inequality, so we're not done yet. Using these possible solutions, we're going to do something called testing them out. So these are our test points. Once again, I'm going to draw my number line like this. I don't know, let's start negative 5. Let's put some points on this thing. Okay, so once again, our test points were x equals 1 and x equals negative 3. And our original inequality, it had a less than sign. So because it had a less than sign and not a less than or equal to sign, these two numbers cannot be possible solutions for our problem because these are not included. This is x equals, and we're looking for we're looking for something that's less than. I don't know if that made sense, but I'm just gonna keep going, and maybe once I draw it on the number line, it's easier for you guys to visualize what I'm talking about. Anyways, so, wow, I made a mess of this. Back to what our test points were. X equals 1, x equals negative 3. So because these are not included, the circles that I'm going to do, they're open circles. They're not closed circles like they were in the previous example. Now for quadratic inequalities, we're going to have to test out different sections of our number line. So this is a section over here, this is a section, and then this is a section. So let me pick something from this section. Let me pick negative 5 and test out negative 5. Test negative 5. So let's plug that into our original inequality, which was x squared plus 2x less than 3. Negative 5 squared plus 2, negative 5. Alright, I'm going to need more room than that. Is it less than 3? Is 25 minus 10 less than 3? It is not less than 3. That means that this is invalid, and this whole section of the number line, this cannot be an answer. Let's test out a point from this section, this middle section. Let's test out 0. Again, x squared plus 2x less than 3. That's our original inequality. We're testing a 0, and we get that 0 is less than 3. That is true. That is a true statement. So this is a valid part of our inequality, or a valid part of our solution set. Now let's test this side. Let's test this 3 over there. We're going to test 3. Again, x squared plus 2x less than 3. That's just our original inequality. 3 squared plus 2, 3. That's 9 plus 6 Is that less than 3? No, 15 is not less than 3. This is invalid. So our solution set is between negative 3 and 1, but not including negative 3 or 1. So let me just rewrite that so you guys can see what our number line would look like. And let me choose a different color. So open circles for negative 3 and our 1, and the solution set is everything in the middle. So I have no arrows here like I had in our previous example because this is it. It's a closed set. This is our solutions. These are what our solutions can be. Nothing beyond this. Nothing on this side, nothing on this side. Only what I have here. So I really hope this helped you guys visualize inequalities better, and I hope this gave you a feel on how to solve them. If you guys have any questions or concerns, please feel free to comment that below. I know I say that a lot, but really I do mean it. I really want to help you guys out, and I'm really happy to answer any questions that you guys